In the previous video, we have discussed one property of decomposition, that is dependency preserving, right? And in this video, we will discuss the second property of decomposition, that is lossless join decomposition. This is mandatory property for decomposition. It means the decomposition must be lossless. The dependency preserving property, that is, you can say it's not a mandatory property. Why so? Because sometimes it is not possible to get dependency preserving BCNF decomposition, right? But up to third NF, it is always possible to get dependency preserving decomposition, right? That is why somewhere it is written that the dependency preserving property is what? Optional, right? But when it comes to property of decomposition, then there are two properties of decomposition: dependency preserving and lossless join decomposition, right? I hope you know what is decomposition and why we do decomposition. Basically to perform normalization, means to convert a relation into higher normal form, right? If a relation is in 2NF and we want to convert it into BCNF, then we will decompose that relation into multiple relations, right? That is decomposition. That is why we need decomposition. Join means combine, to combine something, right? Or to merge. And lossless means without any loss. Simple English meaning is this thing, right? Now the meaning of this complete word is what? Lossless join decomposition in the context of database. That I will discuss with the help of a proper example. What is lossless join decomposition, right? See, suppose I have a relation R, right? And I have performed decomposition on this relation to convert it into higher normal form. Suppose I have decomposed it into R1 and R2, two relations only. You can decompose it into R1, R2, R3, multiple relations, right? Suppose here I have decomposed it into R1 and R2, right? Now, if I ask you one question and we have performed our operations and all, but sometimes, suppose after some times, we need to combine these two relations, right? Now the question is, if I combine these two relations, again in simple terms I am saying combine word, or you can say if we join these two relations, obviously we are going to perform natural join operation here, right? So if you will join these relations, then should you get the same relation R? Yes or no? Here means after combining, after joining these two relations, should this resultant relation be equal to this original one? Definitely yes, it is common sense, right? Or you can say that, see, this is the relation original one, parent one, and this only we have decomposed this into two sub relations, right? And after that, once you sometimes later when you will join these two, then definitely you will get the same relation, right? Exactly same. Whatever the value of R, whatever the data in R, exactly same data should be present in this R after joining, right? If this is a case, then it is, you can say that lossless join decomposition. So in simple terms, what you can say, what does this property say? That a decomposition of a relation R is said to be lossless if it is feasible to reconstruct the relation R from decomposed subrelations using joins. Then you can say that that decomposition is lossless. I am going to write down the summary of this lecture at last in form of 3 or 4 points, right? And we will also discuss with the help of 1 or 2 examples that the decomposition is lossless or not. How to find out that the decomposition is lossless join decomposition or not, right? Now suppose I have decomposed this relation into two sub-relation R1 and R2. Now you have to check, is this decomposition lossless join decomposition or not? Now obviously for that you have to join these two relations, you have to combine these two relations, right? So you must know what is join operation, how to perform natural join on relations. So let me give you a quick introduction of natural join operation with the help of an example. See, I am taking a simple example. Suppose I have these two sub-relation R1 and R2, right? The data is this one, small relation I am taking. Now, what is the result of Cartesian product? First of all, I am going to tell you Cartesian product, because natural join is improved version of Cartesian product. Then only you can get it better, that what is natural join. So, how to do Cartesian product of R1 and R2? Simple as what? Obviously, we will do what? in R1 I am having AB, in R2 I am having BC. So in Cartesian product of R1 and R2, this would be the resultant table, right? Now Cartesian product is what? See, the first row of this R1 would be combined with each row of R2, right? Means here we have 1 1, then it will be combined with first row, then again we have 1 1, then it would be combined with 1 2, then again 1 1, it would be combined with these three, 2 1, right? Second is, again the second row would be combined with each row, same third row would be combined with each row. This is what Cartesian product, right? So the answer is, so this is the Cartesian product of these two, means each row of one relation would be combined with each row of other relation, right? So the resultant, here we have what? 9 rows, 3 into 3, right? Now what is natural join? This is improved version of this Cartesian product, right? Now in natural join, out of these records, you will consider only those records in which, see, here the common attribute is B, right? So you will consider only those records in which R1 dot B, R1 is the name of this relation, is equal to R2 dot B. B is what? That common attribute in these two. So if you have common attribute in the relation, then only you can apply natural join. I'll also discuss if no common attribute is there, then what will be the result of natural join. First of all, so now see, here this B is of R1, this B is of R2, right? So now R1 dot B, R2 dot B, both are same, so we will consider this record. And see, I am taking like this 1 1 1 1. Here also 1 1, we will consider this also. In this R1 dot B is 1, R2 dot B is 2, we will not consider this one because this condition is not satisfied. So this would not be included in natural join, this tuple. Here 1 1, so definitely you will consider this one. Here also 1 1, so we will consider this one also. Here 1 2, we will not consider this one. 2 1, we will not consider this one. 2 1 not equal, so we will not consider this one. 2 2, it is equal, so we will consider this one. So now the result of natural join would be this one only. Now see, here B and B both are duplicate, right? So no need to write down again B, you just write down single B. So the resultant table, how you will write? Like this. The natural join of these two would be this one. Only 5 records would be there. In Cartesian product, 9 records would be there. Now if no common attribute is there, suppose here I am having R1 as AB and R2 is CD. So I am asking you R1 natural join R2. What would be the result? Because there is no common attribute, so we cannot apply this condition. So the result would be same, you just do Cartesian product and that would be the result of natural join as well, because there is no common attribute. In that case, the result of Cartesian product would be same as the result of natural join, right? If there is no common attribute. And if you want to join, suppose R1, R2, R3, R4, multiple tables are there, sub-relations are there, and you want to join all these. So at same time we cannot join all the 4 because the join, this one is what? Binary operation. So at first just take 2, either you can say R1, R2, suppose I am taking only 3, or you can take R2, R3, or you can take R1, R3. Suppose I am taking these 2. So R1 and R2 after joining becomes suppose R1, R1, 2, after that you can join it with R3. Like this you can perform join operation. All the type of these, all the variants we will discuss one by one later in all the examples, right? So I hope you got how to perform natural join, right? Now check, this decomposition is lossless join decomposition or not. I have decomposed this into R1 and R2, so R1 is having these records, R2 is having these records, right? Now perform R1 natural join R2. If after joining these two you get the same table as R, exactly same records, only 4 tuples, exactly same tuples, then you can say that it is lossless join, otherwise not, right? Now see what you will get. So here the common attribute is B, so just apply this condition, right? So here we are not going to combine this row with each row of the R2. We will combine this with the row of R2 in which this B value is same as of R1. See, here B value is 1. So can you combine this with this first one? Yes, because here also B value is 1. So the one record would be, I am not going to write down B 2 times because that would be duplicate. Only one time you are going to write 1, 1 and 1. Can you combine this with this? Yes, because here also B1, here also B1, right? So 1, 1, 2. Can you combine this row with this third one? No, because here B value is 1, here is 2. Can you combine with this one? No. Okay, now the next one. Can you combine this with the first one? Yes. This with second one? Yes, because 1 and 1, B value is same. So 2 more tuples. Now can you combine this with this? No. Can you combine this with this? No. Now this one, 3, 2. Now can you combine this one with this row? No, the value is 1, here B value is 2, not same. So we can combine this with only this record. So 3, 2, 1, and we can combine this one with this only. So 4, 3, 2. I hope you got that. We will get this result only, right? Now see, in the original one I have 1, 1, 1. Yes, we got this one. 2, 1, 2. 2, 1, 2. Yes, we got this one. 3, 2, 1. Yes, we got this one. And 4, 3, 2. Yes, we got this one, right? But these two records are extra records. Now please don't say that this is lossless. Why? Because we got everything, whatever is there in R, we got everything, and even we got something extra. So it is not lossy, it is we have gained something, right? No, the extra is very dangerous when you are dealing with decomposition, right? We are not going to accept any extra record. Yeah, extra is good in real life because I know you will be happy if someone will give you something extra, but in this case it is very dangerous. So this is not lossless. You must get exactly same relation as the original one. No less records, no extra records, right? So this property ensures that you will get exactly the same relation as the original one, right? After joining the decomposed relations. No extra tuple, no less tuple, right? And maybe suppose I am taking this decomposition R1 and R2. Here I am having AB, here I am having only B. Although this decomposition is logically not possible, but suppose you have given something like this and you are asked that tell me it is lossless or not. Definitely by looking at this only you can see it is lossless. Why so? Because here I am having C, but here I am not having any attribute C, right? So see, the one first property is what? The union of attributes of the decomposed relations must be equal to the attribute of the original relation, right? If suppose I am having I have decomposed a relation into R1 and R2. So you can say that attribute of R1 union attribute of R2 must be equal to attribute of R. Definitely, right? So if we have BC, then it's fine. ABC, union is ABC and attribute of R is also ABC, right? Second property you can say, suppose there is no common attribute, then I have already discussed the result of the natural join would be same as the result of Cartesian product, right? And in Cartesian product we are getting extra tuples. I have already discussed here, right? So in that case also it is lossy, it is not lossless. So there must be common attributes between the decomposed relations, right? Suppose I have decomposed into two subrelations. So you can say attribute of R1 intersection attribute of R2. Intersection should not be phi. It means there must be some common attribute, at least one common attribute. If you do intersection of AB and BC, you will get what? B, and that is not phi. If you will get intersection of like this, CD, suppose I am having one more attribute D, AB and CD. Is R1 and R2 having any common attribute? No, right? So definitely by looking at this only you can say it is lossy, it is not lossless. No need to check that, do the natural join and all, because definitely after natural join you will get something extra in the resultant table. But here see, this property is satisfied, this property is also satisfied in this case, but still it is not lossless. So there is one more third property also that is very important. See, union is ABC, fine, common attribute is there, fine, but still it is lossless. Why so? Because here see, this B is having duplicate values, right? Because of this one, this is having duplicate values, so it will be combined with 1 and 2 rows. It is also having duplicate values, it will be combined with 2 rows. Here it's fine, it will be combined only this row and this row. So one important property is what? The common attribute must be a super key, or you can say a candidate key. If the common attribute is super key of either R1 or R2, or you can say if the common attribute is super key of at least one subrelation, then definitely that would be lossless join decomposition, right? I am having two subrelation, so common attribute is B. If B is super key of at least one subrelation, either R1 or R2, or maybe both. If B is super key of R1, then also it would be lossless. If B is super key of R2, then also it would be lossless. If B is super key of R1 and R2 both, then also it would be lossless, right? So let us take this type of example now. Let us take this decomposition. R1 is having AB and R2 is having AC, right? First of all, see the union of these one, attribute of these one, ABC, union of attribute of these subrelation is ABC is equal to the attribute of R. Okay. Do you have any common attribute? Yes, I have common attribute, right? Now check this is lossless or not. Now first of all check using natural join. I am going to do natural join R1, natural join R2. So the common attribute is A. So we are going to join based on this A. See the first row. Can you combine this row with this first one? Check the value of A, here also one, here also one. Yes, definitely I can combine with this A, right? So the answer is 1, 1, 1, 1 tuple. Second, can you combine this with this? Here value of A is 2, here value of A is 1. No, value is not same. Can you combine this with this? No. With this? No. Okay, second one. Can you combine this with this? No. Can you combine this with this? Record yes. So the next tuple is 2, 1, 2, right? Can you combine this tuple of this one with this one? No, because value of A is not same, value of A is not same. This you can combine only with this, and I guess now you go to this, you can combine only with this. So next record is 3, 2, 1, 4, 3, 2. This is the resultant natural join table. Now you can see it is exactly same as the original one. So this is what? Lossless. This decomposition is lossless, but this was not lossless, right? See now, here you can say A is what? You can see directly you can see here A is what? Super key, or you can say candidate key, right? Using A, candidate key of either relation. I am not saying that the common attribute is candidate key for the original relation. No, just forget it, right? Just check the common attribute is super key or candidate key of either this relation or this relation. It should be candidate key for at least one subrelation. Now how to check that A is candidate key? First of all check A is candidate key for R1 or not. See, if A is candidate key of any relation, then definitely using that we can derive all the attribute of that relation. Now can we derive B using A here, because I am having only two attributes? Definitely using A I can derive A, that is for sure, trivial functional dependency. Yes. So you have to check, can you derive this one? Is this functional dependency possible in this relation? How to check? That already we have discussed one of the previous video. You can check out that video in the side button. Yes, this dependency exists here in this R1. So here you can say A is candidate key for this relation. So no need to check for this one. Fortunately, A is candidate key for this also, you can check it, right? Here in this case, A is candidate key for both the relation. But if A is candidate key for first one, so no need to check for second one. That will be lossless join decomposition, right? So here in short, you can say that three property must be satisfied to be lossless join decomposition. First two I have already discussed. Let me write down again. So here you can say, if a relation R is decomposed into two subrelation R1 and R2, then this decomposition is lossless if these properties are satisfied. Attribute of R1 union attribute of R2 equal to attribute of R, right? Intersection of attributes of the subrelation should not be phi, right? Third property is what? If I have told you, if the common attribute is super key or candidate key for either this relation or this relation. So how we are going to write down into technical terms, right? So you can say common attribute is what? Obviously intersection of this one and this one. So attribute of R1 intersection attribute of R2, right? Must derive all the attributes of either this relation or this relation. So all the attributes of either R1, attribute R1, or intersection can derive all the attributes of this R2. See, this is or, either this or this. If one of these properties is satisfied, see, one is this one is this one, and at least one of these two property, then you can say that the decomposition is lossless. Now suppose the data is not given, only relation is given and functional dependencies are given. In that case, how to find out that this decomposition is lossless join decomposition or not? So that we will discuss in next video. In this video, see, I have discussed in detailed manner just to clear out your basics, that what is this lossless join decomposition, right? In next video, we will discuss few more example of this type and a simple trick how quickly you can find out that if in GATE exam or NET exam this type of question is given, dependencies, or you can say that this type of data is given and you can say this decomposition is given, then how quickly you can identify that this is lossless or not, right? So that thing we will discuss in next video. So now I will see you in the next video. Till then, bye bye, take care.